per seconds. Now come to the applications of NMR spectroscopy. So we can get the detailed information in case of NMR spectroscopy about its structures. We can get the information about the number of NMR signals if it is having number of equivalent protons in a unknown compounds, and it tells how many types of equivalent protons are present in a unknown compounds. If we get 4 signals, it means there are 4 types of protons, and if we are having 3 signals, or it is having 3 kinds of protons. And then we get the information about the chemical shift delta, and it tells us about the position of the signals, and it further explains whether the molecule is having aldehydic protons or aromatic protons, or protons are attached to ethylenic group. Similarly, from spin splitting, as we have today discussed, multiplicity tells possibility of arrangement of groups in a molecules, how the groups are arranged in a molecules. And from the area of the peak, or we get the ratio of types of different hydrogen nuclei present in a molecules. Further, we get the information about the detection of hydrogen bonding. If the sample is having hydrogen bonding, and then we will get the signal downfield, and signal will appear at high delta value. But if upon increasing the temperature, if the signal appears upfield, and that means there must be either breaking of the intermolecular hydrogen bonding, or there will be the loss of hydrogen bonding, means intermolecular hydrogen bonding. And as intermolecular hydrogen bonding is concentration dependent, so then its shift will vary, while intramolecular hydrogen is not concentration dependent, so we will not get any difference in over there. Okay, next it also gives information about the cis and trans isomers and conformers. From the coupling constant value, we get the informations about the J. If coupling constant value J for cis structure is 12 cycles per second, we can strongly say this structure is cis, and for this compound, and if we get the J values around about 13 to 18 cycles per second, it means we can say that our structure is trans. Further, we get the information about the detection of electronegative atom or group. If a electronegative atom or group is present in our compound, and the proton is attached to this electronegative atom, then we can say then our signal will be downfield, and then it will appear at high delta value. Suppose in this case we have proton attached to oxygen, fluorine, or nitrogen, and if even we say if our isotope is nitrogen, and if it is fluorine, if we say fluorine is highly electronegative, if we are recording the spectra for fluorine, then this will appear at high delta value. Or if the proton is attached over here, then we can also say that this will appear at high delta value. Similarly, if the proton is attached to nitrogen, we can say this is less electronegative as compared to fluorine, and in this case we can say over here our molecule will appear at lesser delta value. So we can get the distinction about the presence of electronegative atom or group in a molecules. Clear? And we get also more information about MRI in our next topic.